coming to takeoff point. So takeoff point is nothing but whenever you have a signal, that signal you want to use it for some other purpose, we use takeoff point. So look at here, in takeoff points also I have x1 input, G is the block and y1 output, and this y1 output I want to use it for some other purpose. So I am taking y2 and I am taking y3, right? This is a part of the main block diagram. So in this I want to write in such a way that it is easily understandable or easily taken them out. What will be that? So you can see that other diagram, G I am taking directly y3 and I am taking directly y2. That means I am going to split the takeoff points into two separately. Even if you split that, there is no change in the actual output of the system. Similarly, another example where again same, if you want to split it, but in this case when you are splitting, we have G is coming into picture, therefore y1 G I am taking another output, and again y1 again G I am taking another input, another output. So that y1 I want to direct, I am not taking directly, I am multiplying with the G here, I am multiplying with the G. So this way also we can split the takeoff points. Now another very important set of rules are shifting rules. So there is always necessary in any block diagram reduction, shift some of the blocks after the summing point, before the summing point, or takeoff point and before the takeoff point. So let us see how can we shift. While shifting, what are the care we need to take, what we need to add in the respective branches. Now the first one, so I have one block and after that there is summing point. Now there is a need to change or need to move this block after the summing point, right? So before moving, let us see what will be the output. So it is very clear, x1 into G is x1G, and again I have x2, so both are added, the y is x1G plus x2. Now after shifting also I should get the same thing. What we can do is, first we will shift it, let us check what will be the output. If the output is same, directly you can shift it. Output is not same, let us see where we need to make the changes. Okay, now let us shift it. So when you shift it, what you will get? You will get this diagram. Okay, so x1 summing point and G, and this is the output, and for this summing point x1 is input and then input is x2. Let us take directly x2. So x1 plus x2 is after summing point. If you multiply G, what will be the output? Your output is x1G plus x2G. What should you get? x1G plus x2, the G extra coming. So I need to compensate G. If you want to compensate, wherever x2 is there, introduce one block. That block gain is 1 by G. So whenever you use 1 by G here, directly that will be compensated to the output. So what will be the shifting rule here? The shifting rule is whenever you move the block after the summing point, we need to introduce 1 by G for the other input of the summing point. Similarly, if you want to shift the block before the summing point, so sometimes there is a need to change the block before the summing point. We'll do the same analysis. x1, x2, so therefore this is x1 plus x2 multiplied, what will be the output? x1G plus x2G. Now after shifting, without any modification, I will get y is equal to x1G plus x2, means the G is missing. Therefore for x2 input, introduce one more block and that block gain is G, so that you will get x1G plus x2G at the output level. So this shifting rule is for summing point and block. So similarly for takeoff point and block. Now look at this. Here I have G and there is a takeoff point. You know what you mean by takeoff point. So if you want to get the same signal out for some other purpose, we use the takeoff point. X is input, G is the block, gain, therefore output, what you will get? Xg. Same output I am taking, therefore Yt is also Xg. Okay. Now there is a need to change the takeoff point before the block. So we'll shift it. If you shift it, what will get? y1 is same only, there is no change, but y2 only x is coming. Therefore, actual output is xg, but without any modification I am getting only x. So simply introduce one block here, that block is g, so I will get same output y1, same output y2 for given x. Similarly, we can also shift the takeoff point after the block. When you move after the block, the procedure is same. We need to introduce one more block. That block gain is 1 by g. So these are the shifting rules. Shifting rules are very important. So in reducing the very big block diagram, we'll use 1 or 2 shifting rules. We use some of the takeoff points splitting rules, and also we use summing point splitting rules and loops, forward pass, and all the rules we use. But there are certain problems. Even if you use all the rules, you are unable to get the solution. So in that case, we need to use critical rules. Basically, any rule is to reduce one big block diagram into a single block. Ultimately, we are going to eliminate one by one all the summing points. Eliminating summing points is the reduction. But in this critical rule, instead of eliminating summing point, we are going to add the summing point. So until otherwise there is no solution, we should not use these critical rules. Only worst case we will use the critical rules. Let us see what are the critical rules we have. So critical rule says that we can shift any takeoff point after the summing point, any takeoff point before the summing point. So the first one will see the takeoff point I want to move before the summing point. So I am taking summing point here. So any summing point, we have inputs. So x1, x2, 2 inputs I have. What is the output? y1 is output. Now I am taking one more takeoff point. What will be that? y2. So y2 taking from y1, therefore y1, y2 both are same. What is y1 in this case? x1 plus x2. y2 is also x1 plus x2. This is actual system. Now you want to change it. Before changing, this is what 2 outputs. I want to change it. I want to shift it. Okay, let us shift and see what the changes we need to make. The moment you shift it, there is no change in the y1. You can see here, y1 is same only, x1 plus x2. But when you shift the takeoff point, what will be the y2? Only x1 is coming, x2 is missing. So x1 plus x2 I need. What I can do? x1 plus x2. Plus means again we need to introduce one more summing point. If you introduce the summing point, then only you can add the signal. If you want to multiply, then I can simply use the block. But addition or subtraction, we need to use summing point. Therefore here using 2 summing points, you can connect like this, so that I will get y1 is x1 plus x2 and y2 is x1 plus x2, which is same as the previous one. So after reducing into this, again we use other rules and we'll try to come up with the overall transfer function. The similar way we'll see the second rule, that is shifting the takeoff point after the summing point. So even if you shift that same case, your y2 you are getting x1 plus x2, but I want only x1, therefore subtract that x2. So you take the x2 signal and connect it negatively to summing point, so that that can be subtracted, and y2 is x1 as like the previous one. So this way we can use the rule, critical rule. So all these rules are useful to convert or useful to reduce very big block diagram into a single block which is having the overall transfer function.